So she is also going to help translate.
We've got to take the poster off the wall to walk to a private room. It's ridiculous.
Yeah.
I've never seen something so ridiculous in my life. That's his desire to present his work in front of his poster. We have to make with it.
Okay.
We do what we can.
Just strong voice. Very strong.
Yes, please speak loudly when you ask a question. We are not microphone. So we're going to start at the beginning with just information you may require about the apparatus, how this has been run, and then we'll move to all the experimental results that were done by Alexander. So please, be nice, try to ask short questions and speak loudly. Thank you.
Я предлагаю следующее. Люди по очереди будут поднимать руку, подходить сюда ближе, и мы с ними будем беседовать недалеко от стенки.
Okay. Who has any question on the apparatus?
Before I explain.
So, it's a coiled metallic wire that is supplied. I can do this. I'm gone. Okay, so it's effectively a tube furnace. It's on a malite 50%. We don't know the other elements in there, but it's 50% ceramic based on alumina. It is originally was a nichrome heater wire, but unfortunately that was not able to go to the temperatures required or run for long enough. So he changed to a Russian analog of Cantal A1. It's an iron chrome aluminium alloy, and that enabled him to go to higher temperatures. What's the thickness of the heating wire, roughly? The thickness of the heating wire is 1 millimeter. So it's not pure alumina, it's lower grade alumina. Yeah, just to make sure. Just check on the heater wire.
The thickness of the vessel, right?
The heater wire first.
Да.
In the second experiment, во втором эксперименте, который продолжался более 300, была использована проволока Кантал, российский аналог Нейтраль, толщиной 0,56 мм.
It is 0.56
millimeters. 0.56 millimeter diameter. In the iron chrome aluminium version. Yeah.
In the second experiment during 3 days.
Yeah. The second experiment ran for 3 days.
And what is the input power altogether? Electric power.
The cumulative power.
No, the electric to get the temperature.
Электрическая мощность постепенно поднималась от нуля примерно до 600-700 Вт, и потом при этом уровне была достигнута температура 1200 градусов на поверхности трубки. А потом автоматика, при такой температуре автоматика снизила питающую мощность до 300 Вт.
До 750 вы дошли, да? До 750 вы дошли Вт, а потом снизила до 350. So it was gradually increasing to 750 watts over the time, and when the vessel reached the temperature of 1200 degrees, it was decreased, the input power was decreased to 350 watts.
Снижение мощности показало, что снижение мощности при неизменной температуре показало, что появился дополнительный источник тепла.
So when the power was decreased, obviously from 750 to 350, that was an indication, and the temperature stayed constant. That was an indication there is some process that provides enough of the inner power to heat up and yes, keep constant temperature.
Okay. DC current or AC current? DC or AC?
Переменный ток, но поскольку стоял регулятор тиристорный, это был переменный ток искаженный.
AC.
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 He
So
made
it's
a homemade thyristor stack.
sinusoid or pulse?
It was originally, he tried a thyristor. He couldn't manage to assess the power out of that, so he went to straight variac, and then he's back with this recent one on a thyristor.
Thyristor.
So it was
it's pulse.
Yeah, it was
So the
a
power
pulse.
was reduced gradually, automatically, or it was done manually?
Okay, what I understand from conversations is it automatically went down, and for some reason it went down in steps. Can you verify that?
Как быстро начала мощность снижаться? Вы ее одним скачком снизили или постепенно?
Снижение мощности автоматически происходило в течение примерно часа, и потом поддерживалось на уровне 300 Вт.
So it took about 1 hour to get from 750 to 350, and then it just stayed at 350.
You mean watt?
The power input.
Okay, but the temperature when you decide to decrease, which one? The temperature inside. Temperature inside.
So, они спрашивают, а какая температура внутри? Вы сказали 1200.
It's not quite inside, it's actually higher inside.
Температура на поверхности трубки была 1200 градусов, поддерживалась. Но чтобы внутри было значительно больше, это свидетельствует то, что после извлечения топливо оказалось в расплавленном состоянии.
Это значит, сколько вы думаете там было?
А температура плавления никеля 1440 градусов.
So 1200, that was on the surface.
How much? Sorry.
1200.
1200.
Yes. And after the reactor was cooled.
Of what? Of the reactor?
Of the,
No, you've got a tube furnace, you've got a thermocouple inside the tube furnace heating coil, and then the reactor's inside. The thermocouple underneath the heating coil read 1200 and maintained that as the power input dropped.
Internal temperature 1200.
No, more.
Okay.
Maybe, because it's inside, so maybe the same.
Okay.
But inside the reactor, the temperature was high because the nickel powder was melted. So the temperature was more than 140 degrees.
There's the fuel and the ash.
Before and after.
What is the composition of the nickel? Is it just pure nickel or something?
No, it's not.
First, we asking questions about the apparatus.
Dimension.
Okay, so
We took a sample, and independently Ed Storms did an SEM of the fuel, nickel powder. It looks exactly like the photo that he's had taken here of the same fuel powder, so we can verify this is authentic. With the mean size of the particle of 8 microns.
How many?
Did you
8.
have some results? Did you have some results?
We haven't had the full fuel mix yet.
Okay.
We've not run the full fuel mix yet. It sounds like it's the time to move to the other batch of questions about materials, the results, and the analysis that were done. Please.
Wait. Before. No, about the apparatus.
Okay. Go ahead.
Sorry. Parkhomov was measuring the pressure, and he went up to about 5 bars and then to a vacuum. Can he explain whether he had a diffusion of hydrogen out of the cell, and this is how he got to the vacuum, or how he explained that?
у вас упало
Yes, the question was about the pressure. What she's translating. About the pressure. Why the pressure dropped and then went below 1 bar? Is it about half a bar? Is it about leaking hydrogen, or is it about absorbing
I didn't talk about diffusion.
Diffusion through the alumina tube.
Я объясню, как вообще шел ход давления в процессе нагрева. При температуре, где-то после 100 градусов началось разложение алюмогидрида лития с выделением водорода. Это продолжалось примерно до температуры 200 градусов.
So, first at 100 degrees, when the temperature was just going up, the chemical reaction of decomposition of lithium
Okay.
yes, started. And then, что случилось с давлением?
Давление поднялось при температуре 200 градусов примерно до 5 атмосфер.
So the pressure went up, and at the temperature of 200 degrees, the pressure was about 5 atmosphere. Bar.
Okay, same.
Because of the hydrogen.
Okay.
При дальнейшем росте температуры давление не возрастало, а начало снижаться.
So the temperature was still going up, but the pressure started going down.
Вероятно, это связано с тем, что водород начал поглощаться никелем.
So yes, the explanation is that the hydrogen was consumed.
Absorbed.
Can I add some clarity that's in relation to Arik's question? So in previous reactors, it was fuel bare on the alumina, and because of questions of maybe degrading or increasing the permeability of the alumina, bearing in mind it might have had magnesium and calcium in there, he used a very thin steel shield into which to place the fuel, and that's to stop the lithium aluminium hot metal from eroding. What kind of steel? It's stainless steel, but there's hundreds of
stainless
types.
steel are several thousand. So stainless steel is just generic name, it's not name.
Yeah.
Но я еще не договорил. Что происходит при дальнейшем нагреве? Далее, значит, на следующей фазе нагрева, вероятно, получилось так, что практически весь водород был абсорбирован. И дальше пошел процесс, поскольку не было вакуумирования, то пошел процесс поглощения кислорода и азота. Кислород и азот осел в виде оксидов лития и никеля, и поэтому давление стало ниже атмосферного. И это продолжалось на протяжении нескольких часов.
So he believed that partial pressure theory explained why the hydrogen may have leaked out without having the nitrogen and oxygen getting in, because if the leakage is very small, then it can happen.
Yes.
Repressurize it with hydrogen?
The apparatus wasn't able to do that. It was sealed with alumina, which is... To clarify, on the steel capsule, it allowed easy fueling, clean fueling, and easy extraction of the ash. And to give you an idea of the thickness of the steel, a sewing needle was used to create the gaseous exchange holes in the fuel vessel.
The other thing which might be important is that the apparatus was not evacuated first, so that it contained air to start with, and then hydrogen was added to that air.
So
that's important.
At the beginning, it was not evacuated.
No, it was not evacuated.
It was just
oxygen, 20%.
It had fuel.
20% oxygen. 0 to bar of oxygen.
But
and some air there.
They didn't add hydrogen. It was coming from the lithium
aluminum hydride.
Yes.
But there was air there to start. It was not evacuated. It was not purged first.
Louis, watch.
So the hydrogen wasn't added on purpose. It just came from
the hydride.
Yes.
Peter.
So if there was air here initially,
Strong.
Heat from the water reaction?
There's very little air in there.
What was the volume of dead volume in the cell? The dead volume. The spare space wasn't occupied by fuel or fillers.
Hydrogen oxygen, maybe a joule or two. That's all. There's very little air there.
How much? Volume.
Если включить объем воздуха в манометре, то получается около 2 кубических сантиметров.
About 2 cubic centimeters if you are including also the volume of the line.
How many? 20?
Two.
Only two.
Cubic. It's
So
very small.
you had the available space in the reactor. Then you had some tubing that came out of the reactor and into the manometer. I can never say that word. The pressure sensor that goes round in a loop. It's got a bit of air in there.
But only a bit of it.
So maybe totally maximum 5. Totally.
2. He assessed it.
Okay, but something like
Call it 500.
Yeah, okay.
Can we
The longest run 3 days? Is that what I hear?
Так долго, 3 дня, да? Последняя версия.
Сначала шел постепенный нагрев, примерно 12 часов. После того, как вышел реактор на рабочий режим, он продолжался примерно 3 суток. Значит, прекращение работы реактора произошло из-за того, что сгорел провод нагревателя.
Okay, so it took 12 hours to heat it up to this working condition, and then it worked for 3 days, and then the heating element just
break it. Okay.
Дальше. Значит, после этого, поскольку сам реактор остался цел, был изготовлен новый нагреватель, и через сутки работа была возобновлена, и еще продолжалась в течение суток.
То есть вы еще раз 12 часов разогревали, а потом еще
В этом случае уже разогрев продолжался всего 3 часа, потому что не надо было разлагать.
So then some fixes been made, and the new heating coil was built. So that took a day, and within 3 hours, so this time within 3 hours, the temperature was raised to 1200, and it worked for another day.
And the temperature, the power input, how much was that it was required to use to get to 1200 degrees on the second run?
What was temperature required?
The power.
Power required to reach the temperature.
За 3 часа опять все разогрели.
He answered that question.
Yeah.
Second time.
После того, как была достигнута температура 1200 градусов, потребовалась мощность около 600 вот уже не 300, а 600 нагрева. И примерно она снизилась немножко, градусов на 50.
А потом поддерживали какую?
Потом поддерживалось 1200 градусов, но там получился, если в первом случае
при какой мощности поддерживалось?
Около 600 ватт.
Нет, 600 вы нагрели.
Ну так и было.
И так и держали. Ну а в чем тогда, собственно, фокус?
В первом случае КОП получился примерно 2,5. А во втором случае, поскольку там снизилось до 300 градусов, здесь снижение небольшое произошло. Поэтому КОП получился 1,3, 1,5, значительно меньше.
So the second run was a bit different because it required 600 watts to heat it up to 1200, but then the efficiency was only 1.3, so the power didn't really been reduced that much. So the answer was around 600 watts.
I have a question. When he did the calibrations, did he do calibrations? And when he did the calibration, did he fill the tube with just nickel powder?
Just inert, okay, something inert.
Did he fill the tube
in the
with
dummy run?
Some dummy material.
Let's just ask how the calibration was done.
Yeah.
Расскажите нам, пожалуйста.
The question was about how did he do the calibration, and did he fill the tube at the calibration?
With some dummy material.
Dummy material.
Перед тем, как запускать реактор в рабочем режиме, он был нагрет без наличия топлива. И исследовалась зависимость мощности, требующейся для определенной температуры. И потом, когда уже был запущен реактор в рабочем режиме, избыточное тепловыделение определялось при сравнении кривых нагревов.
А вы туда не клали ничего, просто знаете как? Положили никель, да?
Первый раз пустой.
А когда-нибудь не с пустым вы калибровали? So it was calibrated empty. to answer your question, no, it was not calibrated with nickel powder. And then the comparison was done empty, and the power required to heat it up versus the reactor which has a fuel, and the power required to keep it at the same temperature.
Peter, you have a question?
Более детально можно технологию калибровки, определения пол прочитать.
Okay, so the poster will still be here, so more details.
How many grams of fuel, please? Total fuel.
Примерно 700 миллиграмм топливной смеси.
Okay, so it's 0.7 gram. It's less than 1 gram.
Of what?
Fuel.
No, I think it's 0.7 of the lithium hydride.
No, is it the composite fuel or just the nickel?
On top of that. Ask him again.
The total maybe.
Всего вместе, все. It's all together.
And what was the ratio?
А какая, понятно, сколько чего?
10% алюмогидрida по весу.
So 10% by weight of the hydride aluminum.
Okay.
If you double the amount of material, then you can turn off the power supply.
Very smart.
I know how to calculate.
Why didn't you do it?
Peter.
Речь идет о том, что, а если вы увеличите в 2 раза, да, так сказать, сколько вы туда положили, там вам вообще греть не придется.
That's a silly question.
So can we have Peter's question? He's been trying to get in for some time.
My question is not stupid at all.
My question is about insulation. So some years ago at MIT, we were working with a system that went up to 1500 C, and we could insulate it, and it worked at 40 watts, so it could maintain 1500 C with 40 watts, no problem. So you've got much more input, 10 times more input to get to a little bit lower temperature. So if you have decent insulation, you could be running factor 10 power gain of the power grill.
Okay, so Jean-Paul's first question was about if it doubles the temperature, the power, if it doubles the
I can answer that question.
So the answer was that this material was bought just...
I didn't say the second one. So, and then Peter asked a second question about if you add insulation that will give better yield in terms of excess energy generated.
So we talk about material, right?
No, the insulation.
So he tried some of his early reactors in a bed of alumina powder. The problem is when the reaction started, there was no way to control the excess heat, and it easily melted the coils, or the reactor tube got breached. So he moved on, to having the watercolor inventory, but then...
So you mean that he was...
he used a lot less power.
He was reducing the input power to 0, and yet the temperature was rising until it burned off.
Well, I guess if you turn... I think actually... Well, ask him. Did he ever have a moment where he turned off the power and it still went to failure? My understanding is it always failed before that, but anyway.
Расскажите, пожалуйста, в какой-то момент был, что вы прямо совсем уже, так сказать, мощностью брали до нуля? Или никогда такого? До 350, понятно.
Такое было, когда, я работал с реакторами первой конструкции. Произошло перегорание нагревателя, и в течение 8 минут держалась температура 1200 градусов, когда уже не было никакого подогрева.
Сколько минут?
8 минут.
So, during the first phase, during the first phase, it actually got so hot that, the power was decreased to 0 because it failed, and the temperature stayed at 1200 for 8 minutes without any power in.
So we're talking about this graph here where it was in insulation and the heat coil failed, so there was 0 power going in. And it maintained 1200 degrees for 8 minutes. Flat, it wasn't going down.
So self-sustaining for 8 minutes.
This reactor of first design, not this.
Just went off.
The temperature, which one?
Yeah. Whatever was self-sustaining stopped.
Sharp.
Any questions?
Yeah, decrease. Just stop. It turned its own switch off.
Epoxy.
No, I agree, but you still have a slow decay of temperature.
That is slow if you actually stand graph.
Here?
Break.
Why is that so
Heater, break.
when the power is down and the temperature drops so quickly? Hydrogen recombination and reabsorption by hydride. That's my bet. No, it's my bet.
Is he making it up on the fly?
Вообще, как быстро? Вы не помните, сколько стран уменьшилось? Сколько ему заняло? 30 секунд до нуля. Вообще странно, да?
The baseline is 800, by the way, there. The baseline is 800.
Oh, it is?
Yes.
Oh, degree C, but
So you're looking at about half a minute to go from 1200 to 800.
But the baseline is 0 in terms of power.
No, you don't know the profile after. It's not the data's not there.
Yeah, it's 0 for power.
So yes, it's not dropping to 0 or room temperature, so it's 800.
The baseline is 800.
But 0 for power. The self-sustained part between the blue line and the red line is 8 minutes.
Material? Is people interested where
Yes.
material came from? So material, yes, I already asked. I was the first one, so I asked where the material came from. The material came from the department store.
Chemical shops.
Chemical shops.
Off the internet.
Supermarket.
In Russia.
The reason we are asking is that we found, at least people told us, that the nickel was very dirty with a lot of carbon
and oxygen.
Nearly 7% carbon on the surface, at least.
And where did Ed Storms got it?
No. Alexander, you gave it to me. I sent it to America. It was sent from Bob Higgins to Ed Storms.
Okay.
Они там через друг друга все это передали.
Это интересно, потому что в исходном не было углерода. Или был?
Мы вас спрашиваем. А вы делали анализ? А как вы делали анализ?
Can you buy 50 kilos and spread it?
Just a second. So the claim is that material was okay before it was given to you, and then Ed Storms all of a sudden has found the carbon content. So I'm asking if the analysis was done in Russia before, how exactly was it done?
Анализы, которые вот удалось до сих пор сделать, это значит, анализ, который был при помощи электронно сканирующего телескопа, микроскопа и лазерно, и путем облучения лазера, они как-то вот не позволяют надежно определять углерод. Поэтому я не могу ничего сказать о том, был ли, но согласно, значит...
Знаете, мне бы название технологии, то есть это EDS, EDX, собственно, что это? То есть лазер, да, фасиентор, лазер есть, да, дальше что? Кто это делал? Куда вы его дали? Какой институт?
Институт общей неорганической химии.
Можно найти как-нибудь.
Кому интересно, они могут подойти и мы посмотрим.
Okay, so for the details on analysis, you will need to come over later because it was obviously done in the different place, the institution, and the technique that was used for me is unclear. But presumably, I don't know, EDS, EDX, I would expect.
Yeah, it was EDS, EDX made by...
He's talking about his own analysis.
And there is another one they did in Russia.
Вообще, как можно EDX?
Те анализы, которые
Что они показали?
Они углерод не определяют.
Что они показали?
Они углерод не определяют.
Ага.
Ну ладно, давайте. So the analysis what we did in Russia, there are some problems to find the light elements. So the carbon is
difficult
too.
Okay.
And there are some problems with electron scanning microscope. Maybe this analysis was made in America. We don't know how they catch the carbon. Because for many apparatus, the samples are covered by carbon. So
maybe.
Maybe carbon.
Okay.
The analysis you did was before the, not post, but
before or after. They make analysis of the powders after experiment.
Can you repeat?
Did you make analysis of the powder before and after the experiment? There is some big difference, something changed. Oh, hello. Oh, my God. Okay, maybe bigger.
I think this is the picture you all want. This is the money shot.
Yeah.
Can I just say, Alexander, this is only one of 3 laboratories, and so it's only provisional data. Please do not take this to heart, okay? He doesn't want to say this is how it is, but it's the before and after fuel analysis of the through-day run.
Okay, by what technology?
Yes. I have a date.
What technology?
What technology?
The methods of analysis. Second ion mass spectroscopy. Second ion mass spectroscopy or SEM.
And what is the element that changes the most?
Microscope.
No, with laser, SIMS.
Yeah, SIMS. Secondary ion mass, But it's only one lab, and Alexander doesn't want to stand behind this until he's got the other 2 labs come back and he aggregates the data. So please do not take this as gospel, okay?
One laboratory result.
Please.
There's an increase in silicon. The chlorine disappears.
What about the lithium?
They haven't got the data on that because of their size.
Like that.
What about the nickel?
Well, why is the chlorine in your sample analysis there for the fuel?
That's the money shot.
Флор как-то объяснишь. Just thinking, not sure.
Are we done?
I don't, does anyone else have any questions?
Yes.
Everybody.
The other labs that are doing the... Is there any lab that is doing the mass spectrometry where we can see isotopic change in nickel, for example?
Yes.
What's the 1, 2, 3? Oh, isotopic, okay.
No, it's not very big, very few.
Okay, very few.